Hey guys, we're going to get into the topic of square roots because we're actually going a little backwards. It's going to help us big time with some of the material we'll see tomorrow and next week for sure. Okay. Anyway, square roots. Here's some basic vocabulary. You want to stop the video here, write this down, look for definitions in that e-textbook found on Schoology. Look at the definitions, the examples, and it'll facilitate, again, the classroom discussion and your understanding overall. The first problem we're going to look at is something like this. Now, before I get into it, I want to kind of preface this material, okay, with some prior knowledge, which is the following, right? Check this out. If I take 1 squared, I get 1, which is stuff we already know. 2 squared is 4. 3 squared is 9. 5 squared is 25. Whoops. I'm going to squeeze in 4 squared. Alright, 1, 2, 3, 4, 5, and then 6 squared, 36. 7 squared, 49. 8 squared, 64. And 9 squared. Okay, so these are squares, right? We're dealing now with square roots, which is really just the opposite. Here, I'll prove it, right? So if I take the square root now in backwards of 81, what should I get? 9, right? Keep on going backwards. Square root of 64. Okay, so hopefully you caught on to the pattern. The square root of 49, which is up here, should give me a 7, right? Okay, which it does, and I'll do one more. And the square root of 36. Alright, so anyways, that's a whole concept, right? You understand squares, now the opposite of square roots. Now with that said, when you look at this problem, it's asking you the square root of 43. Okay, as soon as you see the square root, okay, it's kind of intimidating, but what you do is you apply to your prior knowledge, and you're like, hey, square root of 43, right? Fall somewhere in between these two, and that's the point. So that's how we're going to express this. We're going to be like, hey, this guy falls between square root of 36. Okay, right? He's still bigger, but it's also less than square root of 49. How are we going to use that? Now, again, can you go calculator? Yes, but in this case, the whole purpose is to do a little mental exercise in some of your own pen and paper math skills. So the purpose of that is the square root of 36 you know to be 6. This one is 7. So therefore now you can estimate without a calculator what the answer is. And it might be safe to say what? What would you think is a good estimate? Okay. You can say approximately at least 6.5 would be good. I cannot say 5. I cannot say 8. It's got to be between 6 and 7. And that's going to be sufficient. Simplify the expression. Alright. Now, there's some couple of things that should be said here. The first one is that this radical sign, okay, the square root sign, can distribute. So I'm going to go and distribute it here so that you can pick up on one of the properties. Alright, so the fact that it's being applied to the whole fraction means you can distribute it to numerator and denominator. Now, to simplify, that basically means you've got to clean it up as nice and neat as possible. So what I'm going to do here is I'm going to break it into its prime factors. This is what you're going to have to do. Now, if you're not great at it, I'll show you how to use a calculator in a bit. Alright, anyways, 98 prime factors are 2, and that's 2 times 49. 49 is 7 times 7. Okay, these are prime numbers, which means they can only be divided by 1 in themselves. 128, it's a long list. It's 2 times 64, 2 times 32, 2 times 16, 2 times 8, 2 times 4. Okay, now, whoops, and I forgot to put this little symbol here. Okay, so this is the way it's taught. It's important that you really appreciate this process. So what's going to happen here? First of all, let me indeed verify that we have the same values, okay, the same two expressions. So this is 49 times 2 is 98, 2 times 2 is 4, 8, 16, 32, 64, 128. Okay, so they're still equal, but what you're going to do is you're going to identify pairs, okay, and you're going to basically kick them out the radical. So, right, because this is essentially 49 squared root of 49 is 7, so it's going to pop out of the radical. And this guy's lonely, he has no pair, so he stays inside. Okay, in this case, pay attention here. He's got a pair, so he comes out, right? This is square root of 4, a 2. This is another 4, so he pops out. Here's another 4, and he pops out of the radical. He's left inside, so this is what we have left to work with. All right. So now these guys that qualify to come outside is 2 times 2 times 2, which is 8. So he stays the same. Here we have, right, 2 times 2 times 2 is 8 square root of 2, and it ends up producing what? 7 eighths. All right. And this is what the problem asks. Now, the only concern that you might have is some of this factoring, so let me show you what you can do. Okay, so let's go calculator. Okay, now the number that I was working with is 98 and 128. So what's a quick way to do this, or maybe a way to check it? Alright, let me show you here, guys. You go to menu, I think it's numbers, and then factor. Okay, so if I'm curious about the factors of the 98, look what I get. I get 2, and then 7 squared, which is 2 times 7 times 7. Right? 2 times 7 times 7. So now let's go ahead and check out the factors of 128. 128. And I get 2 to the 7th, so that's 2 times 2 all the way, 7 times, right? So let me go ahead and double check I did that right. So I have 1, 2, 3, 4, 5, 6, 7. So I did it right, and that's one way that you can approach this with some help. All right. Next, simplify square root of 7 over square root of 5 by rationalizing the denominator. Now in mathematics, it's not appropriate to have and express your final answer with a square root or radical underneath in the denominator area. So the quick fix is this. Okay, so if you ever get an answer like this, it is the answer, but you want to clean it up, make it appropriate. So all you have to do is multiply, okay, by the denominator. That's the quick fix, at least this portion that's underneath the radical. And other than that, the math works out pretty easy. Check this out. What you get here is, okay, they can now be combined under the same radical. So now you have this. Okay, the 7 times the 5 under the radical. Underneath here you have the 5 times the 5. And now we can take care of the math, and we get square root of 35 over square root of 25, right? And we got to ask ourselves, what was the purpose of that? We still have our square root. Well, because now the square root of 25 is known to us. It is equivalent to 5. Okay, and this process allowed us to rationalize the denominator, meaning it no longer has that square root, okay, as a final answer. So this is equal to this, but this is the appropriate way to express yourself, okay? And lastly, subtract these two expressions. 3 square root of 3 minus 14 square root of 3. This is very easy to do. I want to give you a similar example here on the corner, okay, that's going to help you in the future. So let's just pretend that it's square root of 3 you have x, right? So instead of square root of 3 I have x, I put x. So you guys know how to do this, right? It's 3 minus 14 times x, which gives you negative 11x. Right? Because you're able to combine like terms, right? He's got an x, he's got an x. All you have to do is take 3 minus 14, you get negative 11. Same thing here. Okay? You can consider this a portion here. Okay, this expression as kind of a variable. Alright? It'll help you identify or determine when two terms are identical, and more importantly, when you can and cannot combine them. So since we do have a match, we simply have 3 minus 14 square root of 3, which is negative 11 square root of 3, and that would be your final answer. We're under 10 minutes, guys. Please jot these down so you can use them. Come with questions, comments, concerns tomorrow for class. Thanks for your time.